Hello and welcome, my dear grade 8 students, to the session for today on lesson 7.1 Graphing Systems of Equations. Our learning outcome in today's session would be to determine the number of solutions of a system of linear equations. Number 2, to solve system of equations by graphing. Number 3, to solve linear equations by graphing system of equations. And number 4, to use graphing calculators to solve system of equations. Now we'll not be doing the last learning objective because calculators are not allowed in your exam. So the last one we will do without the calculator, and vocabulary words for today's session would be system of equations, consistent, independent, dependent, and inconsistent. So you're going to understand the meaning of all these words in today's lesson. So stay glued and let's discuss the important points for the session. So let's learn about the graph of system of equations. So a set of two or more equations with the same variables is called system of equation, and you will be looking at the variables x and y. So there will be two variables and there will be two equations which are given to you. So that will be your system of equation. You have to solve that system of equation, and what you will be getting will be a solution of the system of equation. That solution would be represented as an ordered pair, that is solution of both the equation. So ordered pair would be x comma y written like this, and that will be the solution. A system of two linear equations can have either one solution or infinite solution or no solution. So these are the three kinds of possibilities for the system of linear equations in two variables and two equations. Now you have to understand the meaning of the word consistent, independent, dependent, and inconsistent. Very important. So consistent means it has a solution. So now that solution may be one, that is one ordered pair, or it may be many. It may have infinite solutions. Still it is going to be consistent. Independent if the consistent system of equation has exactly one solution. So if you get one ordered pair x comma y, one value of x, one of y, then it is independent, and the graph or the the graph of the two equations will intersect at one point. So you will see a graph like this which meets at one point for independent, for consistent system of equation. For dependent, let's change the color. For dependent, you will see a consistent system of equations having infinite number of solutions. Infinite means many solutions. So the graph are going to be the same line, one over the other. So if one line is here, the other line is on the top, so it will look something like this, same line graph. It means it has unlimited or many solutions or infinite solution. That's called dependent. Inconsistent means no ordered pair satisfy both equations, so lines are parallel and there is going to be no solution. So the graph will look like this, one line and the other line. There is no meeting point. They both are parallel to each other. So let's now summarize the concept. As a summary, let's summarize the concept. So if you have two system of equations in two variables, then the number of solutions can be categorized into three types. So the first type is when you have one solution or unique solution, or if you have infinitely many solutions, or if you have no solution at all. Now, the first two categories, it is said to be consistent system of equation. Consistent means it has a solution. It may have one solution, it may have many solutions, but still it has a solution. Inconsistent means it will not have any solution. So inconsistent system of equations will not have any solution to them. Now let's see what the graph will look like. The graph for one solution will be intersecting at one point. So the two system of equation will have different slopes. So the two lines or the two system of equations will have different slope m1 and m2. Okay, so this is how it is different slope. For infinitely many solution, it will be having one line graph. That means m1 is equal to m2 and b1 is equal to b2. So same equation of lines. For inconsistent, the graph will be parallel lines. So you will check for slope. If slope is same, m1 is equal to m2, but b1 is not equal to b2, then it will have parallel lines or inconsistent system of equation. Once you see parallel lines, you can say it will have no solution, and that's how we summarize the concept. So let's move to some questions now. Look at these two equations. The graph is given to you. So for y equal to minus 3x plus 1, y equal to x minus 3, the blue graph represents the first line and the orange graph represents the second line. Both of them intersect at one point, as you can see. Also, the m1, which is the first slope, and m2, which is the second slope, are different. So when slopes are different, it is one solution. So one solution means this solution. So if you have to select from consistent and inconsistent, then it is consistent since it has one solution. And in independent and dependent, it is independent because it has one solution. It would have been dependent if it has many solutions. So this system of equation, since the two lines intersect at one point, there is exactly one solution. So it is consistent and independent. Let's look at the other one. Here if you see, the slope is same, 1 by 2, 1 by 2, and the value of b is different. So m1 is equal to m2 is equal to 1 by 2, but b1 and b2 are different. So they are going to have the graph of parallel lines, and you can see the first line is giving you the blue line, the second one is giving you the orange line. Both have equal slope, so this is going to be inconsistent system or inconsistent system because it does not meet and it has no solution. Okay, determine each graph shows that whether it is consistent or inconsistent and if it is dependent or independent. So very clearly you could see from here the slope is minus 1 by 2, minus 1 by 2, and b value is 3 here, b value is minus 2, both are different. So m1 is equal to m2, but b1 not equal to b2, so the graph is going to be parallel lines, as you can see from here. So it is going to be inconsistent, means no solution. Look at this one, they meet at one point, the slopes is different. The slope for this one is 1, the slope for this one is minus 1, so they are meeting, they are perpendicular lines in fact. So they are meeting at one point, so they are going to be consistent and they are going to be independent because they have one solution. So you can check your solution like this. Now let's look at the number of solutions, equations in slope-intercept form. Determine the number of solutions the system has. Then check if the system of equation is consistent or inconsistent and dependent or independent. So you can look here, y equal to mx plus b. This is the slope-intercept form. So the slope is equal both sides and b1 and b2 are different. So this is going to be parallel lines because m1 is equal to m2 and b1 is not equal to b2. So you are getting parallel lines. When you have parallel lines, they will not meet at all. So there will be no solution and the system will be inconsistent. Let's look at this one. This is already in slope intercept form. So the slope is 4 by 5. This equation number 2 we need to convert to slope intercept form. So we will keep y here, move the 5x on the other side. It becomes this. Divide by 4 both sides so that this 4 and this 4 cancels, and you have y equal to 5 by 4x plus 9 by 4. Now this is slope intercept form. So what is the slope here? 5 by 4. Both are different. M1 is 4 by 5, M2 is 5 by 4. So when they are different, they will have unique or one solution. So the system is consistent, it is independent, and it has one solution. So this is how, looking at the slope intercept form, you can get the slopes and say without drawing the graph about their system of equations. Okay, now number of solutions, equations in standard form. You are given the equation in standard form. I hope you remember standard form is ax plus by equal to c. So you have to say whether the system is consistent, inconsistent, independent or dependent. So it will be good to change in slope intercept form. So you convert it into slope intercept form by keeping the y here, moving the 6x on the other side. So the slope intercept of the first line is this, and the slope intercept of the second line, this one, is this. Now you look at both the equation, both are same. So when both equations are exactly same, that is m1 is equal to m2 and b1 is equal to b2, then both will have the same graph or the same line. So this is going to be a dependent system of equation. It is having a solution which is many solutions, or you say infinitely many solutions. So because both of them have the same line, the two lines are the same, so it is consistent and it is dependent. Dependent because both the graph will be the same line. So if you draw the graph, it will be like this, one line representing both of them. So that's why dependent and consistent, many solutions. Now, the two system of equation are given to you in standard form, ax plus by equal to c. So convert them into y equal to mx plus b. You always have to convert to slope intercept form if you don't want to draw the graph and you want to say the number of solutions. Okay, so when you convert, the first equation comes out to be y equal to 0.5x minus 2. The second equation comes out to be y equal to 0.5x minus this. So look at the slope. The slope is same, but the value of the b-intercept is different. So these are going to be parallel lines, as the slope is same but the value of b is different. So if they have parallel lines, they don't meet at all, and therefore it is no solution. So the number of solutions would be 0 because it does not have any solution at all. System is inconsistent. Now, solving system of equations by graphing. Now, if the graph is not given to you and you have to draw the graph, then how do you solve the system of equations? So first you will graph each of the equation carefully on the same coordinate plane, and then every point that lies on one equation represents a solution. So this is like one equation, one line, another equation, another line. Similarly, every point on the line of the second equation represents a solution. Now, to find a solution, you will look at the common point where these two are intersecting, like y equal to x plus 4, y equal to minus 2x plus 1. They intersect at minus 1 comma 3. So therefore, the solution of the system of equation is the point at which the graph intersects. So in this example, it is minus 1 comma 3. Since the point of intersection lies on both the line, the ordered pair satisfies each equation. So the solution would be x comma y, the ordered pair, which is the common solution for both the graphs. So let's look at this equation. Y equal to mx plus b. It is given in slope intercept form. So what is the slope? Minus 2. What is the slope here? 3 by 5. What is the b-intercept? 14. What is the b-intercept? Y. So let's draw the two graphs one by one. For the first one, we go to 14 and the slope is minus 2 over 1, which is rise over run. So I rise by 2 units. That means I go down by 2 units and 1. So this is 1 point. This is the next point. Again, I go by 2 units, 1. This is the next point. Down by 2 units, 1. This is the next point. So this is the graph of the line. Now for y equal to 3 by 5, this is rise over run. You go to plus 1, that means this point. You rise by 3 units and then you run by 5 units. So rise by 3 units, you go up, run by 2 units, you go right. So this is the point. So on, you will draw the points and you will get this line. Now these two lines are meeting at this point. So let's see what is the coordinate. The x coordinate seems to be 5 and the y coordinate seems to be 4. So the point of intersection is 5, 4. You can substitute 5 for x and 4 into y into the equation and see if they are true or not. Let's check. Y equal to minus 2x plus 14. So x is equal to 5, y equal to 4. So put it here just for checking. In place of x this, in place of y this. So this is 4 equal to minus 2 times 5 plus 14. So this is minus 10 plus 14, which is 4. So both sides are equal. So when they are equal, it means it is true. That means 5, 4 is the solution of the equation. So what did we use? We used the concept of slope, rise over run. We used the value of b to draw the graph and to look at the solution. This is called solving a system by graphing. You can also use Desmos to solve the equation. So here if you see, the equations are given in standard form, ax plus by equal to c. So first you convert to y equal to mx plus b. That means you write the first equation as 10 minus 3x divided by 5. So y equal to minus 3 by 5x plus 2. This is the first equation. And minus 5 equal to minus x minus 10 divided by minus 5. This becomes y equal to negative, negative becomes positive throughout. So this is x by 5 plus 2. This is the second equation. So both the equations, if you see carefully, the value of b1 and b2 is same. The slope m1 is minus 3 by 5 rise over run, and here the slope is 1 by 5. This is the value of m2. So you have to find the solution of the system of equations. So let's draw the graph on Desmos and see the solution. So when you draw the graph, it is meeting at the point because y was common here, so it is meeting at this point. So it will have one solution where y is 2. Let's solve for x. So I put in y equal to x by 5 plus 2. Y is 2. So x by 5 is 1 or x is 5. So the value of x is 5 here. That's how you get the solution. And the value of this is x by 5 is actually 0. So x is 0. So the point which is solution is 0, 2. This is the solution point. As you can see, both the lines are meeting at the same point. Let's solve this question. Here you are given the equation again in standard form, ax plus by equal to c. So you have to graph the system, determine the number of solution it has. If it has one solution, find the coordinates. Now if you look at both these equations carefully and you try to find the slope, then the slope is same. So if you convert to slope-intercept form, y equal to mx plus b, then the first equation would give you this value divided by 2. So the slope is 3 by 2 for the first equation. Similarly, for the second equation, if you want to convert to slope-intercept form, you move your 6x on the other side, divide by 4 or divide by -4. That's more appropriate because the negative and negative will cancel to give you positive. So this becomes y equal to 4 cancels, 3 by 2x minus 2. So this is the second equation. Now you look at both the equations and the slope. It is 3 by 2, 3 by 2. So m1 equal to m2, which is 3 by 2. And if the slopes are same, but the y-intercepts are different, as you can see here it is 7 and here it is -2. So same slope but different y-intercepts, so the lines are parallel, and if they are parallel they don't meet at all, so it will have no solution, so you cannot find the coordinates. As you can see from the graph also, the lines are parallel. Our next learning objective is to use systems to solve linear equation. There are 3 steps. Write a system by setting each expression equal to phi. So y equal to mx plus b, you are going to convert it in this way. Then you graph the system using your knowledge of slope and p-intercept, and then find the intersection or the common solution. So let's take an example. You are given solve a system of equations equal to this. So you are going to put each equation equal to y. This is also y, this is also y. So y is equal to minus the left hand side 3x plus 8. This is the first equation, and the second equation will be from -4, so y equal to -4. Now these are the two equations you are going to do in step 2, the graph. Here they have used the calculator, but in your ministry exam calculator is not allowed, so do it without the calculator using the concept of slope m equal to -6 by 1 here, which is rise over run, and here there is no slope, only the y-intercept is there, slope is 0. So they are going to intersect at one point, find the intersection point, and if you see the x coordinate comes out to be 2. So when x is 2, you put it back in equation 1, y is equal to minus 6x plus 8, put the value. This is minus 12 plus 8, so y is minus 4. So what is the intersection point? 2 comma minus 4. X is 2, y is minus 4. You can also check your solution by putting back in the equation, and it will give you both sides equal. Now, the last learning objective is solving system of equation by using graphing technology, but since you are not allowed calculator, you will do without the calculator. A graphing calculator is not allowed in exam. So just do in the same way that you see the last question. Step 1, isolate y. Step 2, do the graph without the calculator. And step 3, do the intersection. So if you look at this question is solved using the calculator. You will do it without the calculator. Isolate y. So that means I want y on one side. I'm going to move it here and this number here. So it will become y is equal to minus 5.13 minus 1.3x. Let's write it in slope-intercept form. 1.3x minus 5.3. So this is y equal to mx plus b. How much is m? How much is b? Let's see. If you compare, your m1 or the slope is minus 1.38. Your b1 or the y-intercept is minus 5.13. This is for the first equation. Let's look at the second equation. Again, we isolate y. So 2y is equal to negative 0.36x plus 1.60. Now you divide by 2 both sides, and your y comes out to be negative 0.31x plus 0.80. Now this is in slope-intercept form. So the slope m2 is negative 0.31, which is rise over run. So you raise it to 1, and your b2 is 0.80. Now you will graph the equation just like you did in the last question, and you will find the solution. So approximately your value of x will come out to be negative 5.41, 5.4, and y will be 2.52. So without the calculator, this is how you do the question as in the last method. Just to check your solution, you can do this on quickly on GeoGebra or Desmos graphing calculator. And this is how the two equations would be plotted. When you do the graph of them, they will meet at one point and the solution would be 1.34 for the value of x and 0.78 for the value of y. Just to help you out, I have put the solutions in this video for the questions that are given by the end of your book for the lesson for practice. So you can check your solutions and take help from these answers. So I have also put in some graphs here so you can check the graphs for question 11, 12, 13, 14, 15 and 16. So that brings us to the end of today's session. This was a complete video for all my grade 8 elite students for lesson 7.1 as requested. Until then, this is Miss Ruchika signing off from today's session, and a humble reminder, a kind request: if you like the video, give it a thumbs up, share with your friends, and see you in my next video. Bye students.